Well, hello physics students, and welcome to kind of this impromptu video lecture on motion graphs. This is going to be our debrief to the POGL that we did on Thursday. And basically what I want to go through is just the basic ideas of motion graphs and the connections between these various motion graphs. So on this first slide here, I have a position versus time graph where I see the object is starting at some origin and it is going 20 meters in 5 seconds. Okay, now I want to find the slope of this line. So remember, slope is just rise over run. So my slope here, I'm going to have, well, my rise is 20, my run is 5. So my value of my slope is going to be 4. Now, I made a big point during that POGL to ask you what the units of the slope are, or what the units of the slope is. So my rise units there are meters, my run units are seconds, so my slope is 4 meters per second. Now, the big key here in this POGL is recognizing that, oh wow, look at meters per second. I have a distance unit over a time unit. That means that my slope is telling me how fast I'm going. It's telling me my velocity. So now we can go down to our velocity versus time graph, and we can say, all right, there's 4 meters per second, and it's a constant. It's a constant 4 meters per second because this line is linear. It never changes. So I'm just going to draw a horizontal line there, draw my 5 seconds down here, and there is my velocity versus time graph. Now, that's how we go from a position versus time graph to a velocity versus time graph. Now, let's just, for the sake of doing this, say I wanted to find the area of this shape. Well, it's pretty obvious that this is a rectangle, right? So if I want to find the area of a rectangle, I'm going to take base times my height. So my area is going to equal 20. Now 20 what? Okay, so again, I'm hitting the units hard here. So my base units are seconds, and my rise units are meters per second. If I multiply those together, these seconds cancel out. So what I'm getting here is I'm getting 20 meters for my area. So what that 20 meters is telling me, it's telling me what my displacement is. And that should make sense because take a look at my position versus time graph. My displacement here was 20 meters. Okay, so first step here with position versus time graphs and velocity versus time graphs, we can get the velocity from the slope of a position versus time graph, and we can get the displacement from the area of a velocity versus time graph. All right, so now, previous slide we had position versus time graph and velocity versus time graph. Here I have a velocity versus time graph and an acceleration versus time graph. Now, I'm going to ask us to find the slope of my velocity versus time graph. So again, slope is rise over run. So my rise here is 12 and my run is 6. So that gives me a slope value of 2. Now again, hitting the units hard. So my rise units here are meters per second, and my run units are seconds. So that simplifies down into meters per second squared. So the slope of a velocity versus time graph tells us what the acceleration of that object is, which in this case is 2 meters per second squared. So now I can come down here, similar to the previous slide, and I can create my position or my acceleration versus time graph. Okay, so again, this is a linear graph, so there's no change going on here. So what we have is a constant acceleration. That wasn't a very straight line, but you get the idea. So now, again, similar to the last slide, I'm going to ask us to find the area of this shape. Again, it's a rectangle, so I'm going to take base times height. So my area here is going to be 6 times 2. That's going to give me 12. Again, hitting the units. So my base units are seconds. My height units are meters per second squared. If I multiply those two out, well, this seconds is going to cancel out with one of these seconds. So I'm going to end up with meters per second. So my area there is 12 meters per second. So what is that 12 meters per second telling us? Well, that's telling us what our change in velocity is. If we take a look at our velocity versus time graph, I started at 0. But after 6 seconds, I was at 12 meters per second. So the area of an acceleration versus time graph tells us the change in an object's velocity. So to summarize what just happened and what we just discussed in the previous 2 slides, and to really summarize what you saw in that POGL, we have 3 types of motion graphs. We have a position versus time graph. We have a velocity versus time graph. And we have an acceleration versus time graph. Those are the 3 types of motion graphs that we have. Now, going from a position versus time graph to a velocity versus time graph, the slope equals the velocity. Okay, so from the position versus time graph, we can get what the velocity of that object is. Going from a velocity versus time graph to an acceleration versus time graph, our slope tells us what the acceleration of that object is. Okay, so here's the connection. You're seeing a connection between these graphs now. Position versus time graph gives us the slope of that gives us velocity. The slope of velocity versus time graph gives us acceleration. Now, going the other way, if we go from an acceleration versus time graph to a velocity versus time graph, the area gives us our change in velocity, so the change of velocity of that object. And now from a velocity versus time graph to a position versus time graph, the area gives us our displacement, okay? It gives us our change in position of that object. So this is how these motion graphs are connected. This is the information that we can gather from these motion graphs. Now, later on in this motion graph discussion, we're going to start understanding various shapes of these different motion graphs and understand what those different shapes are telling us about the motion of that object. But for right now, we need to keep in mind how these 3 are connected and what information we can gather from these. So this little graphic right here is going to be crucial for us, and it really simplifies down the information that we can gather from these motion graphs. That's all I have for you, physics students. I hope you have a wonderful weekend. Take care.